Hello and welcome. I'm Tom from the Yunker lab, graduate student here, and today I hope to be showing you a little bit about the universal testing machine that you see in my lab. This machine can be used for two main purposes. It can either compress samples or it can pull samples. And I'd like to be going over some basics about the UTM so that you can learn to use it properly. The first thing that I'll talk about here is this side panel. So this is how you turn the machine on and off. There's an on-off switch right here. There's also an emergency stop switch. And then this is also how you can move the stage up and down, these two components here. And then you can also run your sample or the test of your sample with this button up top here. Lastly, on this panel, there's this switch. The switch is important because this switches between testing mode and setup mode. So obviously in testing mode, that is the direction you want the switch flipped when you are trying to actually test your samples. But if you want to change the implement with which you're going to test the samples, for instance, you want to change the size of the compression plates, then you should switch it to setup mode while you do that. Next, let's talk about the actual kinds of compression plates and stuff that you might configure the UTM with. So there are three main implements that we have here in the Yunker lab. One of them is already installed here. So this is, you see a small cylinder here. This is a kind of compression plate that is used for small compressions on the order of about 1 Newton, for instance. This particular type of compression plate is rated for 5 Newtons, and that should be written on here. It's the 5 Newton plate. In addition, we have usually stored behind the stage here. We have a much larger compression plate that we can install, and this one is a 1 kilonewton, 1 kilonewton compression plate, so it can do everything up to that total. This is what I tend to use to compress yeast when I do that, but depending on your applications, you might want to use one or the other. Lastly, we have these two components, which are the pincers used for pulling a sample, applying tensional stresses. So what you can do is you can remove this compression plate, this steel compression plate at the bottom here. Instead, install one of these this direction, and then you will install the other one the other direction on the piece that moves up and down here, the stage that moves up and down. Next, let's talk about how to actually change one of these items, in case the one that you want to use is not currently installed on the machine. So let's say that I want to run some tests with the 1 kilonewton load cell instead of the 5 Newton load cell that is currently installed. How can I swap the two? Well, the first thing that we want to do is make sure that the machine is either in setup mode or off. Then we can remove the currently installed load cell by turning this, by basically removing this pin here. Now, this is pretty close to the stage, so I'm going to give myself a little bit more space by moving the whole stage up a little ways. So I'm doing that with those buttons on the panel, on the side panel that I showed you earlier. Okay, so now I've given myself a little bit more space to take this off of there. So let's remove the pin. There should be a ring up here that we can turn, and you can lock both directions for this pin, or for this ring. So we put it someplace where it's pretty loose. Then we can pull the pin out, and this should drop. You want to make sure to support this while you pull the pin out. Now, this is load cell that we are removing, so we can place it maybe behind the UTM like so. and this is the one that I want to install instead. Call it up here, and then, alright. And now it's just the same process in reverse. I pop this on here, I push the pin in, and then I can tighten this ring down. Just like so. Now, one thing to pay attention to is there are actually 2 pins on this load cell, for instance. There's the one at the top, near the stage, and there's also this one at the bottom, which allows us to actually remove this pin and take this piece off. Now, the load cell is still the same. This red piece is the load cell. That still has the same sensitivity and still has the same capacity. So this is actually not the pin that we want to remove if we want to change the load cell. That is something to keep in mind. We want to remove the top one, not the bottom one. Okay, the next thing to do, you'll notice this wire hanging off here. We need to actually plug this wire in so that the computer knows which load cell is installed. The way that we change the connection to the computer is actually around the backside of the side panel over here. So let's walk around to the backside here, and you'll notice these VGA-looking inserts. And these are the opposite end of those wires, and what they're plugged into over here is how the computer communicates with the UTM. So you'll notice that they should say on them, for instance, this one says 5 newtons or 5N right there. That is the 5 Newton load cell. So we can undo this one. Which is a little challenging as I'm holding the camera, if I'm being honest. There we go. We pop that out of there. Right. And then we can pop in place the 1 kilonewton load cell, because that's the one that I want to use. So one thing that you might notice while you are changing the load cell is that the machine will turn itself off as you do so, which is totally normal. When you want to use it again, you just got to turn it back on. So now that we're at the computer, we can open up the program for the UTM, and to do that, everywhere you see one of these blue cubes here, all throughout this area, those are all the different versions of tests that people have come up with. To start off, I would say just open one of them, and then you can change it however you might like, and just save it as a new file. So now we have the program loaded. You'll notice that when the machine is off, you get this red bar down at the bottom telling you that you can't actually do anything. So if I go over here and turn the machine on, that should change. Now you see it as a gray bar, and that is because I still have the machine in setup mode. When I put it into test mode, it should turn white, or you might sometimes see green, depending on certain situations, which we might talk about in a minute. For now, I'm going to keep it in setup mode while we finagle around with the actual machine. This bar up here is how you actually run the machine. And so we'll talk a little bit more about what each of these things, what each of these buttons does. A lot of them are grayed out at the moment because we're in setup mode. Then you see a series of tabs here. Right? So we've got series layout, and this gives us the main screen that we usually look at, where we plot here it's plotting force versus time, but you can change these axes by right-clicking, and you can configure the curve graph, and this will give you these options for what you want the x-axis to be, what you want the y-axis to be, what units they are, etc. Now, these other tabs are called Specimen Layout, Media, Video Capture, and Wizard. Now, of these, really, the middle three are not used very often. The ones that I use the most are the Series Layout and the Wizard tabs. So let's talk about those first. We've already talked a bit about the Series Layout, so now I'm on the Wizard tab here. The Wizard tab is how you actually set up the tests that you want to run. So on the left-hand side, you'll see a list of sort of topics, and we can click through them real quick. But in each of these topics, you'll see on the right-hand side a bunch of options that you can change. So, starting off, pre-test topic, we're going to specify what kind of test that we want to do. So there's two choices, either a tensile test or a compression test. Since I've got the compression plates in, I'm choosing the compression test. The specimen shape, this is something that I think engineers really like to play around with because they can put different shapes of material in there. So right now we have it as slab. We could also just not specify a specimen shape. It could be flat, round, pipe, and tube, whatever else. But what this eventually does is I think allows for different correction factors for calculations about stiffnesses and some sort of bulk moduli information. For the most part, especially if you're testing something more amorphous, it doesn't really matter that much, especially because usually you just want the data of force versus time, and this category does not change that. This next line here says test with indenter. What this means is that if you had a compression plate that had let's say a needle on the end of it, that would be the indenter into the material, and then it wants to know the cross-section of this indenter if there is one on there. We don't have any indenters. We only have the compression plate, so I've never checked that on. Now, the next stuff is where we start getting into some of the more important stuff. This fourth line down is called tool separation at the start position. And what that tells you is how far apart do the compression plates start. In this particular document, they start at 45 millimeters apart from one another. And we can change that by changing the actual value in this box. We could also change the units over here. And then we can also, if we have set it up by hand on the side panel using the up and down keys, we can set the current position of the crosshairs to the start position by clicking this A button. So if I do that, then it changes to 78.08 millimeters, which is how far they're separated at the moment. Let's see. Now, next line after that. Speed start position is the name of this. So what this does is when you are not at the start position and you want to approach the start position, this is the speed at which the crosshairs will move to reach the start position. Right now it's set to 200 millimeters per minute. That seems totally fine because there's nothing to test during those types of movements, generally. You can change what's called the approach path. I've never finagled around with this, so I don't actually know exactly what this means. So I would suggest not worrying about the approach path. These next two lines, gauge length correction and height of the additional tools, I generally have gauge length correction checked on. I don't really understand what it does, if I'm being honest. These are relatively unimportant. And then lastly, we've got these last two lines on the pretest page that talk about preload. And what this refers to is, when do you want the recordings of force and displacement to start? And they will start at this preload number. So the plates will come down, and they will approach the sample, and then they will start pressing into the sample. And here we have it set to not until the plates feel 5 newtons of force will the test actually start recording. You can obviously change this however you want. I think if you just put in 0, it would start from the beginning. But generally speaking, it's a good idea to have some preload on there. Now, the speed to the preload tells you, once you hit start, how quickly are the crosshairs going to move until the preload value is reached. Generally, this is a fairly fast number, maybe not as fast as the start position speed up here, but here, for this particular test, we have it at 100 millimeters per minute. In the past, I have changed that to be a slower speed, especially if you're dealing with a very stiff sample, because you can reach this preload very quickly if you go too fast, and if you can overshoot it, right, because the computer's only so fast. You'll notice, actually, that as I click around into these different boxes, these diagrams come up on the left, which are supposed to give you an indication of what these things mean. That's very helpful if you find yourself a little bit lost. Okay, let's go to the next tab, Test Parameters tab. Now, here is where we can control things about the actual testing period. For instance, we can control how many times the compression plates come down. We can control the value at which they stop the test. We can control how long the test duration is. We can control the speed at which the crosshairs approach or manipulate the sample. And we can control an upper force limit, where we say, if we hit this limit, shut the test off for sure, because we might be damaging the compression plates or the load cell. So, this second line here says type of measurement phase. And this is where you're really going to be changing whether you are doing what's known as a creep test or some other kinds of tests, like cyclic loading is another one that I've used quite often. So in the cyclic loading, we can do the test multiple times in a row, basically. And we can test sort of aging in the material. A creep test is basically just the compression plate comes down, it holds for a little while, you choose whether it holds a force or whether it holds a particular distance, and then it returns after a while. And this is how you can control what is the method of creep. Right? You can change that you want the tools to travel X distance. You want the tools to be separated by X distance. You want the plates to experience a certain force. In this case, I've said that it should go to 200 newtons. Once the plates are at 200 newtons, they're going to hold it. So hold time for creep test is this next thing. We hold it for 15 seconds. That's what I've set this to so far. Type of hold, again, we say this is force controlled as opposed to position controlled, so we're going to hold it at 200 newtons for 15 seconds. Instead, we could reach 200 newtons and then for 15 seconds hold the same position and measure the force over time, for instance. And that's how you would change that here on this next line. You can control how quickly the creep test occurs. So we approach the start position with the start speed. We approach the preload position with preload speed. And now we approach the creep position with this creep speed. And this is generally going to want to be a much smaller number. Right now I've got it set to 2 millimeters per minute. Now this last checkbox here says that you can begin the recording at the point of the load application, or if you uncheck it, it will begin it at the start of preload, for instance. In this area, we have the force shutdowns. So generally, I keep this as an upper force limit, which for this load cell we've specified as 1,010 newtons. And really, if you properly set up your test up here, you should never encounter that, but that's just in case. Now, I want to not just talk about a creep test, though, because although that's a very standard type of test to do, I found myself doing cyclic loading quite often. And as you click through these different categories on the cyclic loading page, you can tell sort of what each of these things is supposed to represent. So we have the number of cycles, we've got what force are we going to go to each time, or, for instance, what position will we go to each time. We can specify how long that position will be held. We can control if it's going to be the position that's held, or if it's going to be the force that's held with this line here. We can change the backup force, so maybe we go up to 200 newtons, and then we come back down to 50 newtons, and then up to 200 back down to 50, or something along those lines. You can change that here. You can change how long you're going to wait before going back to the 200 newtons then. Okay, I think I've hammered this into the ground. Like I said, as you click through these, the visualizations over here tend to be pretty helpful, so I think that that's something you should pay attention to. The next several topics here on this side are less important than these first two. These tell you something about how you want to, what kinds of things that you want the computer to calculate about your sample afterwards. To be honest, most of these things I don't even, I never really check any of these boxes. Control parameters are sort of like the advanced settings of the UTM. You can click on this expanded control and you'll get this layout up here. You'll get an extra tab under here called the control layout, where you can control the force and the strain controller is what they're called. Basically, you get to control how quickly these controllers are obtaining information about the test that you're running. For the most part, I think you should not have to worry about this, and if you do, then I think you should probably talk to myself or Gabi about it instead. Media layout, I don't even know what that does. I've never unchecked these boxes before. And then these parameters, these are just like if you wanted to export the results of the test to a document, they have a standard series of things that you could export, basically. But I never really do that. Instead, I just prefer to export the raw data. Okay, let's get out of this wizard tab, and let's instead start running a test, just to see how that works. So now I've loaded a piece of cardboard into the machine. If I switch the machine from setup mode, where it is now, to testing mode, you'll notice both that the bar at the bottom switches from gray to white,
and also that several options up here switched from being grayed out to being possible to click on. Now, let's talk about what these buttons are. But for the most part, they basically control the machine. The first one's called the machine button. Now, I don't think you should have to use this unless you're doing something very advanced. It allows you to manipulate the controllers of both the crosshairs and the load cells, and allows you to connect which ones are communicating with which, and how is that getting to the computer. So I don't think you should have to use that unless you're doing something kind of crazy. These next four buttons, though, are important to running any test. This one here is called the start position, and that brings you to the start position that we set already. So if we hit back, or if we hit that, the crosshairs should approach whatever we have told it to approach in the wizard here. Next, you'll notice that this is actually reading 0 force at the moment, but sometimes it won't read 0 force at the very start, so it's nice to tare basically the scale before each sample that you run, and that's this button up here. Now we can start and stop the test with these two buttons. So if we start the test, I should have it set up to descend until it hits 200 newtons. It should hold that for about 10 seconds, and then it should go back up, and that should be the test. So if I hit start, and then I take you off the tripod here, we'll see the compression plate moving down. You'll notice a flashing down arrow telling us that it's currently moving downwards. And as the compression plate hits the piece of cardboard, you'll notice the force reading jump from 0, where it is now, to something non-zero. And we've started recording that, and that should continue to increase until we hit 200. So we're just passing about 25 now. You'll notice next to the force reading there, we're also recording the distance reading. So this is how far in, I believe that's millimeters, the compression plate has continued since the test started. Now there you are. We hit 200 newtons. I had it at position controlled, so it held that position for 10 seconds, so you see a decay in the force as some sort of viscous rearrangements are made. And now the compression plate is going back up until it hits some threshold amount of force, and then the test will be over, and it'll go back to the start position. And there it is, returning to the start position. We'll see it over here. Going back up. Piece of cardboard has been sufficiently smashed. Okay, so now that we have run our sample through, you'll notice this actually took me a couple tries. We can rename our specimen to something Tom Cardboard. And then we can save it. So what we would do is all the tests that we want to save, we could highlight, and then you would right-click, and you can say Excel Export, and this should export exactly the data that we see here. Oh, it looks like Excel is a little bit out of... it's a little bit old on this computer, which is, the computer is not hooked up to the internet. And so you'll see that each of the specimens that I suggested are put in their own tab. This one was obviously not a good test, but this is the one that we just ran. And you'll notice that it exported both the time and the force in these two columns. Now, let's say instead I didn't care about the force. So I could configure the curve graph, and I could say, well, I don't really care about the force that I measured. I instead care about the tool separation in not even millimeters, let's say microns. And now it'll give me this tool separation as the tools descended during this time. They held the same position for 10 seconds and then went back up and then finished the test. But let's say I didn't care about that being on the y-axis. Let's say I care about force on the y-axis and then the standard, or the tool separation on the x-axis. Oops, back in microns. Now we can see that if I blow this area up, that the tool started here, went, the tool separation decreased, the force went up, held that for 10 seconds, and came back. Maybe this isn't the most helpful way to visualize the data, but let's say, for instance, that it was. I could export this as well, and it should pop up as that amount of information that we care about. This is how you might do that, and then you could just save the Excel file. Well, we can save this document now by saying save as, and feel free to make yourself a folder on the desktop. I'll just save this one directly to the desktop, and I'll give it a name. Let's say I give the name Tom Cardboard Demo, and it should save as this ZS2 file, which means that it'll save each of these specimens as well as the actual wizard that I have specified here. And if I go back to the desktop, here it is, Tom Cardboard Demo. I'll bring it over to the right in case you want to look at it, to give yourself the ability to just see what I was doing a little bit more closely yourself. So I think that's about all. Thank you very much for listening. I hope this was helpful. If you do have questions about using the machine, then please contact Gabby or myself, or you can always email Peter as well. For cleanup, really all we ask is that you X out of your stuff. When you X out, the machine, I don't know if you heard the click, the machine should shut off as you do that. Please don't log out of the computer. Just keep it logged on, and you should be good to go. If you do find the computer logged off when you get here, we've helpfully written the password up on top of the computer there. All right. Well, thank you very much for listening. Take care.